Hello, YouTube. I'm Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. As usual with my screencasts, I'm going to be discussing the reciprocal system of theory. Today we're going to look at the distinction between Coulomb small q and Coulomb big Q. Of course, in conventional theory, there is no difference. There are no uncharged electrons in conventional theory, just charged electrons. So quantity and charge are the same. But this is not so in the reciprocal system. In the very first publication on this theory, called the reciprocal system, The Structure of the Physical Universe in 1959, Dewey B. Larson, who was my mentor, taught us to distinguish between electrical quantity, small q, and electrical charge, capital Q. In the reciprocal system, an electron may have zero charge or unit charge. There are no other possibilities. One uncharged electron equals 1.602062 times 10 to the minus 19th coulombs small q with dimension equals s. That's electrical quantity, so it's a unit of space. Whereas one charged electron equals 1.602062 times 10 to the 19th coulombs capital Q with dimension or dimensions T over S, and that's electrical charge. So notice the distinction. This distinction is of utmost importance in working with capacitors. Capacitors are known to be electrically neutral. Conventional physics, your college professors, say that capacitors store charge with an equal number of negative and positive charges so that the net charge is zero. Whereas in the reciprocal system, capacitors store uncharged electrons. The dimension of capacitance in SI units is, the definition of capacitance in SI units is 1 farad equals 1 coulomb small q divided by 1 volt. The coulomb here is the coulomb of quantity, coulomb small q, because a capacitor actually stores uncharged massless electrons. In terms of reciprocal system space-time dimensions, the above definition translates to s cubed over t, which is what we find the dimensions of capacitance to be, equals S divided by T over S squared, which is the dimensions of volts. So the CGS unit for capacitance centimeter cannot be correct because I should point out here the dielectric constant is considered to be dimensionless in the CGS system, but that turns out to be incorrect. Now, unfortunately, previous work on the reciprocal system used the centimeter as the unit of capacitance, and that turned out to be wrong. But in the past 10 years, that's the only mistake I've found in the reciprocal system and the only thing that I've had to change. So instead of S, it's really S cubed over T, that is space cubed over T. Also using electrical charge coulombs capital Q, T over S, in the above equation instead of S on the right would give capacitance as S, which is now seen as incorrect. This error can be traced to the definition of capacitance for a parallel plate capacitor as the dielectric constant of the dielectric times the area of one of the plates divided by the distance . Hold on here, let's go back up a little bit. Divided by the distance between the plates. So in CGS, the dielectric constant is dimensionless, but it is not so in the reciprocal system, as I just said. It must be included in the dimension of capacitance. The SI, that's the system, International Rhythmetric System, definition of time constant for a DC RC circuit is tau equals the resistance times the capacitance, R times C. And in the reciprocal system space-time dimensions, this is T squared over S cubed, which are the dimensions of resistance, times S cubed over T. and that equals t, or time, so that's correct. So it's quite interesting. In changing the capacitance dimensions in the reciprocal system from S to S cubed over T, we've also confirmed that the CGS unit is incorrect. Now let's just take a look at the capacitance dimensions in SI. This is in MathCAD here. And using the standard notation for dimensional analysis, we have m, or mass to the -1 power, times L to the -2 power. L is space, or length. T is time, that's T squared, and Q is charge squared. That's totally bizarre. But this is what you're taught in college, and it's just dead wrong. And incidentally, there are conversion factors between this and the centimeter unit for capacitance in CGS. So the farad, as defined here, is really bizarre. And in terms of the standard dimensional analysis, the capacitance dimensions in the reciprocal system are simply L cubed times 2 to the -1. This has been verified now. So, as I said, that's the only mistake that's been made. So please study the reciprocal system. The simplest treatment of the theory is in my book, The Unmysterious Universe. Very simple, very clear. But if you want a really advanced treatise, if you're a scientist, engineer, or professor, you would want to get Existence and Interactions, a computational treatise of the reciprocal system, The True Theory of Everything. And that contains thousands of equations. And included in that is a chapter on capacitor theory. And of course, if you're really brave, you can get the databases. We have a database module, the Microcosmos database, which is for atoms, subatoms, radiation, molecules, compounds, and the Macrocosmos database, which is for astrophysics, astronomy, and that includes everything: galaxies, galaxy clusters, planets, meteors, moons, nebulae, everything. You can find all the work on Amazon or at transpowercorp.com. Thanks for your attention, as usual.